For our senior design project, we did the medical device 2, which is measuring plantar flexion work done by a rat inside an MRI machine. I'm Andrew Meyer,
Mitch Hain.
And Steven Schleibaum.
and this is our project.
So for the design brief and background, the goals of our project were to create a device that could go inside of an MRI machine that would measure the work done by a rat performing the plantar flexion motion. The MRI device is seen on the left. So we worked with a doctor at the med school where he needed to be able to research the correlation between blood oxidation levels, which the MRI will measure, and the power output, which our device will measure.
As far as the concept selection process, we started out with 4 concepts, each using a different way of measuring the force that was exerted by the rat. And then we looked at the customer needs, which was to accurately measure the work, easily change the resistance that the rat felt when he was going through the plantar flexion motion. And then the doctor also needed space for his coil and angle sensor measurement devices. And most of all, it needed to be safe to be used inside of an MRI machine. And the performance measure that we used throughout the project was that it measures the work done by the rat easily and accurately. So seen on the right is the concept that we selected. It uses a pulley with a weight, an interchangeable weight hanging off of it. And after talking with the doctor, we realized that the amount of weight that the rat would need to push was a little bit too much for this design. So we modified the design a little bit to have a more of a lever arm action, as we will show you in the next slide.
This is our finished prototype. The rat will lay here where my hand is, and its foot will push the pedal up, which raises this weight, or this arm, and weights can be placed here to increase the resistance, and an angle sensor will be placed on this side to tell us how much the shaft is rotating, and thus how much work is done, and how much power is done.
So for future actions, the next immediate step is to attach an optical encoder or an angle sensor and a coil mechanism. Then we need to perform tests in an MRI machine to test functionality and any calibration needs. Then we would make adjustments based on customer feedback. In the long-term test, we stay in contact with the customer in case modifications are needed or a new design is desired.